Alright, in this video we are going to do a little review of multiplying polynomials, especially a binomial times a binomial, sort of a double distributive property if you will. But the most important thing we're going to do is we're going to use Pascal's triangle in a process described by the Binomial Theorem, which will be a way for us to expand expressions like x plus 4 to the third power and get the result without actually having to multiply x plus 4 times x plus 4 times x plus 4. Alright, so it's sort of a shortcut. Alright, first of all, Pascal's triangle works like this. You're always going to start off with the first row is just going to be a 1, and then you have a 1 and another 1. But then after that, what you do is you take any two numbers and you add them up, and then that gives you the number in the middle. So 1 plus 1 is 2, so that's going to be a 2. Now the ends will always be 1s. So for this square right here, I have to do 1 plus 2 is 3. And 2 plus 1 is 3. 1's on the ends. When we come down to this row, this is 1 and 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Alright, so this is how you complete Pascal's triangle. So of course here will be a 5. This will be 10. Alright, 4 and 6. Another 10 from the 6 and the 4. 4 plus 1 is 5. And you could do this however far you want to go. I'll just do one more row for now. So this will be 6 and 15 and 20. Alright, 10 plus 10. 10 plus 5 is 15. And then 5 and 1 makes 6. Alright, and again, the ends are always going to be 1s. So if you understand the process that I just did, you should be able to generate Pascal's triangle anytime you want. You don't need a chart to fill in. You could just do one yourself. Alright, start off with that and you go, oh, 1 plus 1 is 2. Put some 1s on the end. Okay, 1 plus 2 is 3. Put some 1s on the end. So you don't need the chart to do this. You can just do it on your own paper. Now, what good is it? Well, it turns out that if we are doing a binomial expansion, alright, if we're doing something like, you know, x plus 2 to the third power, or x minus 5 to the fourth power, anytime you're doing a binomial and a power, you can use this to give you the coefficients of your result. Now, what happens is, you just need to understand that you start with degree 0. Okay? Because anything to the 0 power is going to be 1. So that would just give you 1. Okay? But from there, okay, if I have some binomial, I guess I'll put an x plus y in here. Alright? If I had a binomial to the first power, these will be the coefficients. And so on. Binomial squared, I will use these coefficients. If I have a binomial to the third power, I will use these. If I want to do a binomial to the fourth power, these will be my coefficients. And a binomial to the fifth power. And of course, if I want to do a binomial to the sixth power, I will use these coefficients. Now, what do I mean by that? How do I use these coefficients to make the answer? Okay, to expand the binomial. All right, well, let's get back to the paper. All right, first let's do our review problems. Okay, so problem number 1, we simply do the distributive property. So 2x to the third power times 7x squared, that's going to be 14x to the fifth power. All right, 2x squared times negative 5x. 2 times negative 5 is negative 10. X to the third power times x is x to the fourth power. So notice I'm adding the exponents as I multiply. Okay, so that should be your answer to number 1 right there. Number 2, we have to do this sort of a double distributive property. So I start with the 5x and I ignore the negative 2. So if I distribute that, let's see, 5x times 4x, that is 20x squared. 5x times 3 is going to be 15x. Okay, then I distribute the negative 2. All right, so ignore the 5x now. Negative 2 times 4x is going to be negative 8x, and negative 2 times 3 is negative 6. Okay, of course, we will then combine like terms. So I will put these like terms together. So in the end, I will have 20x squared, and this is going to be plus 7x minus 6. So this would be my final answer. All right, so here again, we have to do this sort of double distributive property. If we distribute the x, then that's going to give us x to the third power, and then plus x squared, all right, x times x. Then x times negative 5 is negative 5x. And then we will distribute this negative 1. All right, negative 1 times x squared is negative x squared. Negative 1 times x is negative x. And negative 1 times negative 5 is positive 5. Combine your like terms. So I've got like terms here. Okay, I've got my x squared and my negative x squared, but they just cancel each other out. Okay, so these are just gone. All right, I've also got like terms here. Okay, so I'm going to have x to the third power. Negative 5x and negative 1x, that's negative 6x. And then that leaves our lonely plus 5 all by itself. Okay, so that should be your answer number 3. Number 4. First we distribute the 4x. Okay, 4x times 2x. All right, we're talking about 8x squared. 4x times 6y, that's going to be 24xy. Now we will distribute the y. Y times 2x is 2xy, and y times 6y is 6y squared. All right, now these are in fact like terms. So just watch out, we will put those together. First we'll bring down the 8x squared. 24xy plus 2xy is 26xy. And then plus our 6y squared. Okay. Now it's time to take it to the next level and see how we can use Pascal's triangle to help us do things like this. Pascal's triangle gives us the coefficients of the answer, all right, our expansion. So first we need to look at which row we need. So we're dealing with the third power, degree 3. So just remember, the very top of this pyramid starts with degree 0. So this is the 0 row, this is the row degree 1, degree 2, and so this is the degree 3 row that we're going to be dealing with. So these are the coefficients that we need, 1, 3, 3, 1. So just start by writing down those coefficients. Okay, 1, 3, 3, 1. I'm purposefully spacing them out so there's room to do some calculations in between. These always start off positive, so just put plus, plus. Okay, so now, here's what we do with the x and the 4. Let's start with the x. This problem is degree 3, so the x is on the left, so I'm going to start off on the left, and I'm always going to start off with the degree that we have. So this 1 is going to be 1x to the third power. From there, it will be in decreasing exponent order. So x to the third power, x squared, and then just x. Now, there are no x's left over. That's the last x, so there won't be any x's on the end, on the last term. So that's what we do with the x's. Now, the 4 comes next. The 4 is on the right, so this time we're going to start off on the right with that 4, all the way over here on the 1. Now, the degree is still 3, so I will do 4 to the third power. Now, I'm going to decrease the exponent each time as I move to the left. So I start off with 4 to the third power, but then I have 4 squared, and then I have 4 to the 1 power, which is just 4, and then that's it. There will be no 4s on the first term. So this is almost the answer, but because these are numbers, I can, and not variables, I can go ahead and evaluate this. So I've got, instead of writing 1x to the third power, I will just write x to the third power. But here I've got the 3 times 4, that's 12. So I will go ahead and put 12x squared. Now here, 4 squared is 16. Okay, so that's what's happening right here. So I've really got 3 times 16. That is 48. So I've got 48, and then I've got my x there. And then the last one, 4 to the third power is 64. So I will just have plus 64. All right, and that is how you use Pascal's triangle to expand the binomial. All right, now that process that we just used, all those instructions I gave you, that's what the binomial theorem tells us. It tells us the recipe, it tells us the procedure, what do they call it, the protocol for coming up with this expansion that we just did. All right, I'm not sure whether there's a random 1 here. I'm going to get rid of that. All right, let's move on to number 6. All right, this is still a binomial to a power. It is the fourth power. So as we look at Pascal's triangle, the key is to pick the right row. So this will be the row for degree 4. So these are the powers, these are the coefficients, that I'm going to use. All right? Just remember, you start at the top with degree 0, and you go down from there. 0, 1, 2, 3, 4. So this is the 4th degree. So 1, 4, 6, 4, 1. So here I go. 1, 4, 6, 4, 1. Those will be my coefficients. They start off positive. All right, just like I did before, let's start with the x. It's degree 4, so I'm going to start off with x to the 4th power, and then I'll do x to the 3rd power, and then x squared, and then x. Okay, now I need to deal with the negative 3. Negative 3 is on the right, so I'm going to start off with negative 3 on the right. Negative 3 to the 4th power. As I go to the left, I decrease the exponent. So I'll have negative 3 to the 3rd power, and negative 3 squared, and then just negative 3, and then no negative 3's on the first term. So now let's just evaluate this a little bit. Okay. So just be careful. Negative 3 squared. A negative times a negative is a positive. So negative 3 squared is in fact 9, positive 9. Negative 3 to the third power. When you do a negative to an odd power, it's still going to be a negative result. So this is going to be negative 27. 3 times 3 times 3 is 27. Guess what? Negative 3 times negative 3 times negative 3 is negative 27. Now this one, when you're raising a negative number to an even power, it will be positive. So this is going to be a positive 64. Okay? So now we're ready to finish up the problem. Our first term is just x to the fourth power. You don't need to write the 1 anymore. Now here, I've got positive 4 times negative 3. Well, that's negative 12. And of course, it's x to the third power. Here, I've got 6 times 9, positive 9. 6 times 9 is 54. So that'll be 54. And then there's my x squared. Over here, I've got 4 times negative 27. I don't remember what that is off the top of my head. All right, so here's my calculator. 4 times negative 27 is negative 108. I should have known that. Okay, so I will have negative 108 x. Okay, because that's this term right here. And here I just have the positive 64, so I'll do plus 64. And that's it. That will be our answer for number 6. Okay, number 7. This time it is the fifth power. So as we look at Pascal's triangle, we look for the row that represents the fifth degree. Okay, and it is right here. So these will be the coefficients that I'm using this time. So it's 1, 5, 10. Okay, so it'll be 1, 5, 10, and then 10, 5, 1. Okay, so once again, oh, and these always start off positive. All right, the x value is on the left, and the degree is 5. So I will start off with x to the fifth power, and I will decrease x to the fourth power, x to the third power, x squared, and x. Now I will do the 2. All right, so I've got 2 to the fifth power. The 2 is on the right, so I'm going to start off on the right. Okay, so I have 2 to the fifth power. And I will decrease by 1 power as I go to the left. So I will have 2 to the fourth power, and I will have 2 to the third power, and 2 squared, and just plain old 2, and that's it. Once you get down to 1 of them, you're done. Okay, because over here it would just be 0 of them, and so you don't have to write anything down. So all I have to do is simplify this. So here we go. Well, x to the fifth power, I can just bring that down. Okay, here I've got 5 times 2. Well, that's 10. So that'll just be 10 x to the fourth power. Okay, of course this 2 squared is 4. So I've got 10 times 4. All right, so that's 40 x to the third power. Now this 2 to the third power is 8. So I've got 10 times 8. Okay, so that's plus 80 x squared. Now 2 to the fourth power is 16. So I've got 5 times 16. That's 80. So this is going to be 80x. And then 2 to the fifth power is 32. Now, you might not know that off the top of your head. Maybe you didn't know 2 to the fourth power either. So if you don't have a chart, you can do it on your calculator. 2 to the fifth power, you hit the 2 and the caret and the 5. And you see that it's 32. All right, so that is it for number 7. All right, okay, using Pascal's triangle and this procedure described by the binomial theorem, this is much quicker than doing x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. Okay, number 8, and I think this is the last one. Okay, and it should be a relatively easy one, except for it has the 3x instead of just x. Okay, but it's the third power, so let's make sure we're looking at the right row. Okay, so this is the row for the third degree. Okay, you see it. So I will be using the coefficients 1, 3, 3, 1. Okay, so 1, 3, 3, 1. And they always start off positive. Okay, now, we just have to be real careful. So instead of just having x, here I have 3x. So what I need to do is I'm going to start off with 3x to the third power. And I'm going to decrease from there. So then I will have 3x squared, and then I'll have 3x. So that's it for the 3x's. I will have none on the last term. Now I will switch gears and do the 2, very much like normal. The 2 is on the right, so I will start off all the way over on the right. 2 to the third power. Now as I move left, I will decrease. So this will be 2 squared, and here will just be 2. Okay, and here there will be nothing. I will not put a 2 on the first term. So it's just a matter of cleaning this up. All right, to be very careful. Doing 3x to these powers, I think I'm going to do that right now everywhere. Okay, so let's just concentrate on the blue. 3x to the third power. Well, 3 to the third power is 27. So remember, I'm not multiplying these. I'm not going to put 9. 3 to the third power, that's 3 times 3 times 3. That's 27. So I'm going to get 27x from this blue stuff here. Similarly, 3x squared, that's 3 squared and x squared. 3 squared is 9, so this will be 9x. Okay? And then over here, it's just 3x. It doesn't have a power. So I've simplified all the blue stuff now. Now I'm going to simplify all the green stuff. Okay, 2 to the third power is 8. So I've got that. 2 squared is 4. So I've got that. And then I've just got the 2 right there. Okay, and there's no more green. And so all that's left is the coefficient. So this was just, well, I meant for that to be red. This is just a 1, so I didn't really need to put it. But then I've got my 3. And I've got another 3. All right, so notice these are multiplying. So I'll just put the little multiplication dot. And then again, it's just a 1. I didn't really need to put the 1 right there. So now I'm ready to write the final answer. Oh, wait, I forgot my x to the third. Why didn't you guys remind me? X to the third power. Don't just let me go on like that, feeling all silly. Okay, so I've got 1 times 27. Of course, this is just going to be 27 x to the third power. Now here I've got 3 times 9 times 2. Okay, 3 times 9 is 18. 3 times 9 is 27. And 27 times 2 is 54. You could use a calculator if you needed to. 3 times 9 times 2. Okay? So I get 54x. All right? And over here, I've got 3 times 3 times 4. 3 times 3 is 9. 9 times 4 is 36. So I'm going to have 36x. And then here I've just got 1 times 8 is 8. So this will be my final answer. All right, and that was the last problem. I hope it was helpful. If you found yourself just copying off of me, please go back and take out a blank sheet of paper and try to redo this problem or any of these problems. Maybe just plain print out the whole sheet again. It's very important that you're not just copying off of me, because that means you don't really know how to do it yourself. Okay, I will see you guys on the next video. Thanks for watching.